So I'm really excited to be here. I'm going to be talking to you today about delivering net zero and using BIM to enable carbon assessment. Before I start, who is working on a project that is measuring embodied carbon? Just sort of by show of hands. Cool, that's quite a few. Who is looking at measuring embodied carbon and trying to work out how to do it? Even more, okay. So I hope that there's some takeaways here that you guys can learn from what we've been doing over the last few years, and hopefully it makes your guys' life a bit easier. So I'm going to go a little bit over embodied carbon, talk about how BIM fits into it. There'll be case studies sort of sprinkled throughout, and then I'll talk about the kind of, I guess, buzzword of the moment is AI and automation, and then towards 2030. So, where do I point this? There we go. This is all centered around how do we reduce carbon emissions in early design, which I think is the hardest place to do it because it's with the least amount of information, but it's the most exciting position because it's where your input of data can make a big impact. And so the opportunities from doing this are around efficient modeling strategies, material data management, and ultimately making informed data-driven design decisions. So I don't think I need to touch on this too much. I think we can all agree we're in a climate emergency. I think the recent events with the weather that we've seen in largely the North Island, but also the droughts in the South Island, signal to us that we are starting to feel the effects of climate change today and that we should all be making big steps towards doing this. We like to think about our impact with you in the middle being the emissions that you guys have from your personal lives, your business, so the emissions from transport, flying everywhere, probably here today, and then the work that you do. And the work that you do has about 1,000 times bigger impact from the decisions that you make every day in your professional lives compared to those in your personal life. And then broader to that is the influence that you can have by making those decisions. And if you don't believe me, here's a project that chose to reuse the existing structure, and by doing that avoided 1,400 tons of carbon, which is about the equivalent of driving return trip from Cape to Cape 2,480 times, which would take you 17 years if you jumped in a car and just went straight. And so that was one decision that a project team made on one project. So there's a huge ability to make a big difference in the construction industry through your professional jobs. And so our goal at Warren O'Mahony is by 2030 with our clients is that all new projects designed by us will be net zero carbon in operation, be 50% more energy efficient and have 40% less embodied carbon. And that last one is what I focus on and what I do as a job. And in my research is trying to turn that commitment into action. So we can't do this alone, and I don't think anyone can, and we really encourage collaboration and the opportunities to gain insights from different perspectives to help us towards getting towards zero and to help others get there as well. So starting off with a little bit of a carbon 101 and embodied carbon. When we talk about net zero, we talk about it using this framework. It has a lot of different definitions. So for energy, it means reducing energy demand first and then focusing on energy generation strategies. For embodied carbon, that means reducing, where possible, the materials and looking at efficient strategies for design, less waste is a big one. And then looking at embodied carbon benefits like biogenic carbon. And through that, looking at procurement like FSC sourced, so sustainable material management. And when we talk about carbon as a general term, it's referring to greenhouse gases, and these kind of are the equivalent of, but is often measured in carbon dioxide. And why we care about greenhouse gases is that thickening of the Earth's atmosphere. Each time we emit carbon, it takes about 300 years minimum to break down, and so our decisions have that time lag on them. So they're really difficult to undo. The impact globally of the building and construction industry is about 39% from building operations and building materials. And in New Zealand, depending on which way you kind of calculate the numbers, it's about a sort of 20% if you look at a consumption perspective, so also the materials coming in externally, or 13% by what we produce. And this doesn't mean that our buildings are better than overseas. It just means that we have a different distribution, and we have things like in agriculture taking up a bigger portion of our national footprint. And so green is embodied. yellow or brown is operational. There are a lot of different targets out there and a lot of different statements. The general trend is that all of them need to be reduced towards 2030 and that you can't just focus on having one half of the equation, that you need to look at both. And what we would like to see is buildings that get closer to 2030 are doing more good than bad, and having a definition around more of a productive or storing more carbon or generating more energy than it consumes, so leaving the site in a better position. So here's a case study just to get you familiar with the numbers. So this is Flowers Site 6. It's in the Wynyard Quarter and it's a timber structure. It looked at a whole of life cycle as well as its structure, envelope and interior. We like to disclose what we looked at because there's a few different methods out there, and so big advocate for transparent numbers. And what this came out as is about sort of 700 kgs of carbon for the whole of life. And you can see that the upfront emissions, so the bits that are emitted before the client gets the keys, is the majority in the embodied, so that happens in a really short space of time. And it also had a big benefit from biogenic carbon because of the amount of timber in the frame and then in the floors. But what gets really interesting is when you can start to do a comparison of carbon intensity across different building elements. And so this is the comparison of that building in green against a 6-story sort of business as usual kind of steel and concrete building. And you can see where it made those savings. So the columns and the upper floors were holding, I guess, a lot of the weight, but also doing a lot of the good. And compared to a typical building that was using steel or like a concrete floor, that made a big impact. So if we were to learn from this project forward, floors and columns are great places for timber. But getting this type of information, this comparison, is what we aim to do in concept design, whether it's against one building versus a baseline or against different versions of that building. So jumping into BIM-enabled carbon assessment. Listening to Amy speak yesterday about the expected experience and caused me to reflect on, I guess, the expectation versus reality when you open up an LCA tool in a design process, is there's this expectation that your model will hold all the information that you need when you need to do it. And that often causes people to delay doing the assessment and waiting for the model to get to this level. But what that means for the project team is when they get the information, they can no longer implement that data to have an impact because the decisions have already been locked in, and in turn, so has the carbon. And so the reality of the situation is you're actually dealing with this box where you've got to try get enough information out of there in an informed way as possible to get a figure that seems about right that'll help navigate the process towards a lower carbon outcome. And so, to be a bit cheesy and go through BIM, word for word, so starting with building, when you start to do an assessment, the first thing is looking at what your building element scope is and what your building life cycle scope is going to be. So there are different ones depending on which standard or method. This one's the ILFI one here. Note, ceilings are compulsory. And then this one here is the MB one that's been developed, and note, ceilings are voluntary. So there's a few different elements that pop into different categories that makes the numbers jump around a little bit, and I'm going to speed up quite a bit. Life cycle scope as before. The information, so this is your database. Here are 6, 3 for product specific and 3 for generic. And then there are different modelling approaches. So you can do volume-based when you've got detailed quantities like steel structures modelled, or area-based, which is where you just know roughly the size of your roof, but you don't know the build-up yet, or length. So you might know where that structure is going to go, but you don't know what it's going to be yet. And so an easy way to approach early concept design is to simplify, measure, and then test. And I'm going to fly through a little bit so that I get to some of the good bits. For early design, measuring those design decisions, so this here is a project that looked at timber and was just looking at the impact of and how much of a reduction it would make. So it's going for Green Star, so it had a minimum of a 10% reduction, so it needed to be sure that it was going to set itself up for that. Here is an aquatic centre in Australia, and so I looked at 5 of them. They had different massing, so this was in Vulcan massing. And what is important is the top number, which is the kgs of carbon per square metre, the carbon intensity figure that we often refer to, was a little bit misleading when you're measuring a building that is changing size as it's changing design. And so the best performance isn't actually the lowest number, which was the 707, because the total tonnes below it. And then the one that they selected looked good, but it was bigger, so it was sort of diluting the figures, but was selected for different reasons. And then the bottom line here, I was testing, looking at functional units, so how many people were going to visit this pool over its life cycle, and looking at the equivalent of what that meant. So it's about the equivalent of driving a car, 1.3 kilometres, versus visiting the pool. Where that gets interesting is when you do that and you look at operational performance. So in Australia, a high carbon building plugged into a high carbon grid. This wasn't the performance of that building, it was a typical car energy use for that typology. And the equivalent, if they kept to a typical energy use, the equivalent was driving 105 kilometres if you were to go for a visit to the pool. And so that, like heating of the water and heating of the air. So just trying to make those numbers more tangible as they are less familiar at the moment. And jumping into a couple of others. This is a school project where we had 3 buildings to look at for the same assessment. And we broke it down into a bay analysis and looked at the performance of the different building elements to try gain an understanding of what elements might be the best to develop on further in the next design phase, noting that the foundations were consistently high because in the massing or master planning stage, the building was put on a floodplain, and that meant it was 1.5 metres off the ground, so there was always going to be a large quantity of materials in that element to achieve that. This one here also had a lot of options tested on it very early on in the design, and was prototyping a lot of different structural systems to try and get large spans made out of timber. And so we selected 34 options across 14 different building elements and assessed them independently, so without the whole building. And that's a great way of getting results out very quickly, because you can reduce down your scope and reduce down your time and get the information out. And if you divide that number by the floor area, you get your per square metre or contribution to your building intensity. And so it followed along as the design team went with different tests and different systems, and even sort of like explored different rotations of these beams and where they were going and how they were connecting to these trees. Very quickly, we also do research with Victoria University alongside my work, and this one we looked at a facade study where we modelled sections of the facade to LOD 400 to really look at where all the carbon was coming from different building elements, and looked at hotspots in the bay. And I'll sneak through very quickly so there's time for questions. Very quickly, the interesting thing was the higher materials or higher quantities of materials weren't necessarily the highest contributors. As you can see, the blue dots that are smaller are contributing the most carbon to that build-up, which when you're working out what to measure and what not to measure, metals, if they're in small quantities, are still worth it because they can contribute a lot, especially if they're aluminium. And also where those materials come from. So if they're coming from, this is an aluminium, if it was coming from Europe, it was 9 kgs of carbon per kg of material, but if it was going to come from China, it was 29 kgs of carbon per kg of material. So thinking about your assessment and your procurement pathways early can make a big difference, even if you can't swap to a lower carbon material. I can touch a tiny bit on this. The main theme is where the specialist sits, and the time in matching those quantities to the databases is what takes so long. If you've ever attempted it, you've probably spent a lot of time also there. You can automate it by having a database remember what mappings you did, and this makes it a little bit faster, but if that specialist is working on 9 buildings in New Zealand and 1 in Australia, then it's going to map the building in Australia to like those buildings in New Zealand, which isn't very useful. So if an AI was to come in and do the job of the specialist, which doesn't currently exist, but will probably pitch up pretty soon, it requires the tools not just to look at the 3D model, but to also be able to take an understanding from the documentation, the databases, and then match that through with the quantities and kind of circulate. So the whole system changes, but becomes really powerful and frees up the specialist to do other things. And so towards 2030, we can stop looking at good versus bad materials and start thinking about being more resourceful with the ones we've got available. And if you take one thing away, is don't use LCA to audit a detailed design. Use LCA to inform an active design process. And we don't have very long left. We're consuming carbon at a ridiculous rate, and this is the carbon that was emitted in about a 20-minute period, so about the length of my presentation. And so let's all work together. He waka eke noa. Thank you.
Basically, just wow. You did go through that end in a very time efficient manner. You've actually saved us quite a bit of carbon by how speedy you were then. So we do have time for questions. And again, there are microphones on the floor. Amy, I can see you near a microphone, so you may decide to ask a question. But the questions that I've got here at the moment are, where shall I start? To Emily, can the net zero buildings be more aesthetically pleasing?
Yeah.
Rude. So what do you think? What's your answer?
I think yes. It's just about what you do with that material, and I think when we've been faced with like limited quantities, similar to kind of the presentation previously around not having that material available, if you get that understanding early enough, then you can innovate with it. It's just about identifying the opportunity to innovate with it at the right time.
That incredible timber structure was very beautiful, I thought. How do you benchmark carbon emissions as a minimum reduction required for mechanical plant used and project sizes? How do you benchmark carbon emissions as a minimum reduction required for mechanical plant used and project sizes?
So measuring mechanical systems is quite tricky. We've done it once before, but there are other studies, so you can use that to kind of, I guess, allow a proportion for it. But generally, benchmarking on a project is either finding a reference building, but setting a reduction target is really good because it encourages you to focus on reducing from a position rather than just trying to hit a target, which might be a kgs of kilowatt hours. So if you're a really big building and you've got not a lot in it, you're likely to hit that, but you haven't actually made any efforts to reduce, so focusing on doing less.
Nice. How aligned are the calculations to standards of local government and international standards for the assessments used? So, do you want me to say that again? How aligned are the calculations to standards of local government and international standards for the assessments used?
A lot of the building scope things are pretty similar. Basically, it's an envelope and a structure is at most commonly the minimum. Where we're seeing a difference is the whole of life, so we set ours to 50 years in New Zealand, whereas internationally it's more common to do that for 60 years. That might mean that when you see an embodied versus operational comparison, the operational carbon might look bigger because they've allowed for 10 years more.
Nice.
I can ask a question.
Yeah, hey, Amy, on the floor.
Only because you said I could.
Yeah, cool. Can we have one of the floor microphones turned up, please?
Only because you said I could.
Thanks.
So obviously a lot of the reduction in carbon is from going from a steel and concrete building to a wood structure, and as we evolve our processes, we'd like to know more than just that. I think the interesting part to me that you showed, so many things, so great presentation, is that you're seeing in the Nordics, in a lot of the Nordic countries now, they're actually requiring that they reuse the steel and concrete structures of buildings and precluding them from taking them down and just starting from scratch, even with timber. And so I'm wondering if you see a true opportunity for not just the reuse of these structures, but the systems inside of them, if we think about them in advance, for, you know, to reuse things like the plant room and the materials, because we know we have to reuse the structure now, and that's coming. What's the opportunity for the rest of the MEP systems and services and plant rooms and bathrooms and things like that for reuse?
I think anything with a shorter lifespan is a great opportunity for reuse because you're more likely to be able to see that through. So if it's got a 5, 10 or 15, 20-year reuse cycle, you're going to probably be there to be the one to help implement the reuse of that system, so that ways that you set that up can be tested and prototyped more regularly, and then I guess more iterations means better outcomes sometimes.
That's a great answer, by the way. I keep thinking future state is secondary market for decoupled systems, with their material passports inside and reuse of those systems as they're taken down. And when we need infrastructure, resourcefulness, I really like that word. So that I'm going to keep that from this presentation in the back of my brain. So I really like that. Thanks.
Awesome. Upcycling. I mean, we're upcycling our clothes already. You should see young people. They're just like buying old clothes by the bucket load. Maybe too much. But they are buying old clothes and recycling them or upcycling them. Upcycle a bathroom? Why does every bathroom have to be new? Okay. What about, have you explored generative design processes for optioneering the best design for purpose? How do you communicate the value this provides with the client?
The value is in, I guess, identifying the project-specific pathway to zero. Every building is a different shape, and so that means the biggest impact from the decisions is going to be likely in a different element. And generative design, yes, I have built little scripts in Grasshopper that quickly regenerate the geometry and the size and shape of the building so that we can then extract out the quantities and measure it.
Are you performing early stage estimation for optioneering?
Yes.
Sort of the same question, eh? That's the same question.
Yeah.
I meant to read this one. Have you noticed a marked difference in cost profile dependent on the carbon emission? I know. Is there a word missing there?
Cost profile dependent on the carbon. I mean, carbon is the cost to offset carbon's changing rapidly. So if it's kind of interpreted like that, then it'll be more expensive likely in a few years' time if we're still relying on consuming a large rate of it, because we'll have to offset a large rate of it, which there's not enough supply, so that means it'll go up. The cost, I guess, to make a low carbon impact on a project depends on how you do it.
Nice. At the early stage of design concept, are you measuring carbon in Revit models or other models?
In early stage, we've measured it from a SketchUp model, a Rhino file, or a Rhino model, and Revit. Depends on what the project team is using.
That QS again, does your study overlay cost? I'm not sure about this question. Does your study's overlay dollars cost? Apart from saving the planet, the client can also save money. So I guess the question is, can you save money on the build and also save the planet at the same time, which makes it much more pleasing for the client?
Yeah. In that project that did the 34 options over 14 different building elements, we did present that in a value engineering session with a graph that sort of had carbon on one line and then cost on the other. And so you ended up with 4 quadrants, which allowed you to quickly categorize those different options into, I guess, bad for planet, bad for budget, sort of good for budget but bad for planet, some sort of compromise in the other way of sort of bad for budget but good for planet, and then I guess a box of good for both. And so that helped focus the conversation to be able to go through those different decisions quickly.
Because it's a complex situation, so you can make different decisions in different parts of the building, I guess.
Yeah, on both cost and carbon.
Nice. Somebody here says, what consideration is made to designing elements for reuse so that at the end of the building life, materials can be repurposed, reducing further embodied impacts?
One of our projects that's on site at the moment, not in this presentation, does have a deconstructible timber structure, as well as all the fixings for the finishes are screws so that they can be taken apart. So yeah, we're doing it more and more. We also have a circular wall system going in on a refurbished building as well, so that is building momentum.
All right, so something you're moving in. I have concerns regarding the demolition stages of a timber-framed building. Mm-hmm. Treated timber is all waste, not recyclable at ALOL, and toxic in waste dumps.
In the, I guess, research space of timber at the end of its life, there's a big gap in knowledge around DOC factors, which is rate of decomposition of organic carbons. Just a lack of studies putting timber in the ground, watching what it does with different treatments and different, I guess, soil conditions. That's why that end of life assumption is at 100%. But there is studies, I'm not doing them, but aware of them, that are looking at how do you account for timber at the end of its life. But if you can include it and not treat it, that's definitely better.
Have you explored genetic algorithms towards an optimization methodology for performance design and carbon content?
No.
No.
But would like to have that conversation.
But she would like to have that conversation, so catch her at afternoon tea. Okay, what about reusing building structures that require strengthening to meet the latest code? Do you have any data about how these stack up against new builds?
Yes, we did a study that looked at a refurbished building strengthening its structure. In that project, they budget cut the facade and they renovated all of the services. And so what it came out as was over the whole of life, it still had a really high energy use. So it didn't matter that they were refurbishing the structure and putting all that, I guess, investing that carbon into continuing it. But the overhaul of the services and its energy use and still with a sort of low performance facade meant that it was still having really high carbon outcomes. So it depends on, I guess, the whole building's metric as to if that's worth it or not.
With Green Star requirement of 20% reduction of baseline, as the industry moves and reduced embodied carbon becomes standard, do you see the baseline also moving?
I think it depends on the method, but having clear and transparent rules around what your baseline is and what you're measuring it. So if you've got a building with a steel and concrete structure and you're measuring it against a timber one, then communicating that. It will probably move as kind of what business as usual changes to be, but always being transparent is important.
Okay, hi Emily. Regarding setting up a carbon reduction target, any advice if the structure has to be steel, not timber, such as a high-rise vertical building?
You don't need to use timber to be a low carbon outcome. That slide that showed where you're sourcing your timber from makes a big difference. And also being aware of, I guess, the impact of different products, and if you don't know, ask. So having that conversation with your suppliers around EPDs, and so being able to make that informed, I guess, specification level decision. Yeah.
From your research, what would you say is the best low carbon model for residential buildings?
Low carbon model for residential. I haven't measured too many residential buildings, but your slab's probably going to be your biggest carbon contributor. And so inside slabs, the reinforcing steel in New Zealand is particularly high. Most of the time it takes up about 40% of its footprint. So if you can procure that from overseas, the shipping won't be anywhere near the same cost as using, say, a coal-fired furnace locally, or use a raised floor system.
As an architecture firm, how do you battle between the need for scalable and modular design with the bespoke and complex ideas that your clients have?
Repeat that one. How do I navigate between?
As an architecture firm, how do you battle between the need for scalable and modular design with the bespoke and complex ideas that your clients have?
I think that project that I showed with those trees was a good way to sort of answer that question. That one was a prototype, so they were testing at a small scale for them to be able to implement across a larger scale buildings. So finding those opportunities that are a comfortable kind of, I guess, lower risk area to innovate so that you can explore the bespoke opportunities that utilize the skills of a really large practice with lots of different specialists, and that can lead to more modular and, I guess, repeatable options.
And how best to measure carbon for off-site manufactured items? Do you include that in your embodied calculations?
For off-site would be just upfront, so A1 to A5, because you don't know the whole of life or the life cycle of that building situation, so just setting it to, I guess, cradle to gate.
Nice. Are you willing to share EPD data with universities?
Yeah, the ones we use are all public databases. We access the one-click LCA database, which has, I think, 150,000 different points. Those were just 6 of them that I showed. And yeah, so we don't hold any private ones.
Whoop, whoop. The answer is yes. Emily Newmarch, thank you so much. Thank you. A lot of questions. Give her a round of applause. That was hard.